See that calm, flat horizon? It's pressing our planet down right now. In fact, Earth is being squeezed and stretched every second by the ocean sitting on top of it. Stick around, because in the next few minutes, I'll show you how seawater bends bedrock, reshapes continents, slows Earth's spin, and yes, even gives us a few extra milliseconds in the day. Shelby here, your Chief Officer Safety. Let's dive in. Let's start with the big picture. The ocean weighs around 1.4 billion trillion tons, or 1.4 x 1021 kilograms. That's about 2% of the moon's mass, spread across 70% of Earth's surface. Each cubic meter of seawater weighs over a ton, thanks to all that dissolved salt. Multiply that by the ocean's average depth of 3.7 kilometers, and you've got a lot of downward pressure. At the deepest point, the Mariana Trench, the water reaches nearly 11 kilometers deep, and the pressure at the bottom is more than 1,000 times what you're feeling right now at sea level. That's like 50 jumbo jets stacked on every square meter of seafloor. Water might feel weightless in your bath, but stack enough of it up, and it becomes one of the heaviest forces on Earth. Earth's crust isn't rigid, it's floating on top of the mantle, which behaves a bit like thick putty over long periods of time. That means when something heavy, like an ocean, sits on it for a while, the crust sinks into the mantle. This is called isostatic depression. Under ocean basins, the combination of thin crust and heavy water pushes the lithosphere 5 to 15 kilometers deeper into the mantle than the land beneath your feet. So in a way, the deep ocean basins are deeper not just because of erosion or plate movement, but because the weight of the water itself is slowly pushing them down. Earth flexes, and the ocean applies the pressure. Now, what happens when you remove that weight? During the last ice age, huge amounts of seawater were frozen into glaciers on land. Sea level dropped by over 120 meters, and the continents were pushed down under the weight of the ice. Fast forward to now, that ice has melted, the pressure lifted, and the land is still rebounding. This is called post-glacial isostatic rebound. For example, Hudson Bay in Canada is still rising at about 1.2 centimeters per year. Parts of Scandinavia have risen more than 300 meters since the last glaciation. Imagine Earth as a giant memory foam mattress. After thousands of years, it's slowly regaining its shape. Earth spins. And just like a pizza dough spinning in the air, it flattens at the poles and bulges at the equator. That bulge? It's partly made of water. Earth's radius at the equator is 21 kilometers greater than it is at the poles. So, if you're standing on the beach in Ecuador, you're actually further from the center of the Earth than someone standing on the polar ice. This bulging, called the equatorial bulge, is created by centrifugal force and the redistribution of water around the planet. Yes, the ocean has literally made Earth chubby in the middle. Here's the wild part. When you move water, especially from the poles to the equator, it changes Earth's moment of inertia. That's a fancy way of saying it changes how fast Earth spins. It's the same principle as a figure skater. Arms out, you spin slower. Arms in, you spin faster. When ice at the poles melts and flows into the ocean, it shifts mass away from the poles, and that causes the planet's rotation to slow down, slightly. Just 1 centimeter of sea level rise slows Earth's spin by about 0.1 milliseconds per century. It may be tiny, but it's measurable. Sea level rise is changing our days. NASA's GRACE and GRACE-FO satellites are like flying scales. They measure gravity variations on Earth caused by shifting mass, mostly water. These satellites can detect as little as 1 centimeter of water change spread over an area the size of Wales. When major ocean events like El Niño shift water westward in the Pacific, GRACE actually sees the gravity field stretch and tilt. Yes, satellites orbiting 500 kilometers above us are tracking the weight of the ocean bending the Earth in real time. If that's not amazing, I don't know what is. Now, why should you care? Well, because this affects everything from sea level forecasting, GPS accuracy, coastal construction, and even submarine internet cables. Cities like New York, Manila, and Rotterdam are spending billions on sea defenses. But if the ground underneath is sinking or rebounding, those calculations change. Understanding how the ocean bends Earth helps scientists and engineers predict the future better. If we drain the ocean overnight, continents would bounce up by tens of meters over thousands of years. Melting Antarctica would raise sea level by 58 meters and deepen parts of the seafloor by several more. The Pacific tectonic plate? It's sinking roughly 1 centimeter every 50 years under the weight of its own ocean. Earth's gravity isn't uniform, it's lumpy. And the ocean? It goes where gravity is slightly stronger or heavier. So yes, the sea moves and the earth bends to its will. So next time someone calls the ocean peaceful, you can tell them, it's not just water. It's a planet-sized force, constantly warping the crust, stretching time, and messing with satellites. And if you enjoy learning wild things like this, well, this channel exists for people like you. Curious minds who love the sea, respect its power, and want to understand what's really going on beneath the surface. Whether it's waves, tides, rogue science, or what happens when things go sideways at sea, we break it down clearly, honestly, and with just the right amount of sarcasm. So if you're into ocean facts, safety myths, or just want to hear a chief officer talk about plankton with way too much enthusiasm, subscribe to the Cruise Ship Safety and Security channel, ring that bell, and I'll see you on the next watch, where we ask the ocean, politely, to stop bending the earth.